Welcome dear students once again to my YouTube channel whose name is Knowledge Entertainment, and as promised in the previous video, once again I am here with more harder problems on trigonometry. So this time we will take some more harder problems, and in the coming 2 or 3 videos more and more harder problems from different competitive examinations like IIT, JEE, MNR, NDA, etc. will be taken in the next 2 or 3 videos. So here are a little bit more harder problems on trigonometry. So first one I am going to take here. The question is, the first question of today is, find the number of solutions. Find the number of solutions of this trigonometric equation tan x plus secant x is equal to 2 cos x in the interval 0 to 2 pi. We have to find the number of solutions of this trigonometric equation in this interval. And now we start the solution. So what we are to do? First of all, we will solve a little bit this equation. This is tan x plus secant x is equal to 2 cos x. Now I am going to write this tan x as sin x over cos x, sin x over cos x, and then this secant x as 1 upon cos x. On the right hand side it is 2 cos x, and now take out LCM of these two. So taking LCM of these two, you will get cos x here, sin x plus 1 in the numerator is equal to 2 cos x on the right hand side. And now this cos x, you take it to the right hand side, cross multiply, and it will become 2 cos x into cos x, that means 2 cos square x. So what you will get now, sin x plus 1 is equal to 2 cos square x. Now this cos square x, you can write this cos square x as 1 minus sin square x. So write down it as, this is sin x plus 1 is equal to 2 times 1 minus sin square x. Open this bracket on the right hand side and take all the terms to the left hand side to get a quadratic equation in sin x. The equation will be 2 sin square x, this minus 2 sin square x will become plus 2 sin square x on the left hand side, and then this plus sin x, and this plus 1, and this plus 2 will be minus 2 on the left hand side, so you will get minus 1 is equal to 0. Now this is a quadratic equation in sin x, and it can be easily factorized. So what will be the factors? The factors will be 2 sin x minus 1 and sin x plus 1 is equal to 0. These will be the factors of this equation, and now the product of these two terms is 0. So either this is 0 or this is 0. If the first bracket is 0, you will get sin x is equal to 1 by 2. If the second bracket is 0, you will get sin x is equal to minus 1. Now we have to find the solution of this equation in 0 to 2 pi. So very simple, you just draw the graph of sin x. This is the graph of sin x. This is 0, this is pi, this is 2 pi, this maximum value is at pi by 2. This minimum value is at 3 pi by 2. Now, this is sin x is equal to 1 by 2 and minus 1. In this interval, the value sin x is equal to minus 1 occurs only here. This is your minus 1. So it occurs only at one point, and that point is 3 by 2. So one of the values of x you are going to get as 3 pi by 2. And sin x is equal to 1 by 2. This is your 1 So definitely in the center of these two you will get 1 by 2, and this line will cross the curve twice. And these 2 points where the value of sin x is 1 by 2, we know that the value of sin x is equal to 1 by 2 in the first quadrant is at 30 degree, that means pi by 6, and then again in second quadrant at 5 pi by 6. So x is equal to pi by 6, 5 pi by 6 and 3 pi by 2 is the complete set of solutions of this equation. So the question was find the number of solutions. So how many solutions are there? 3. So number of solutions of this equation in the interval 0 to 2 pi is equal to 3, and this is the solution of this question. Now we will move on to the second question of today. The next question, it will again be a little bit tricky problem. So the second problem I am going to take is, the question is what is the maximum distance, what is the maximum distance from origin of a point on the curve given in parametric form as x is equal to a sin t minus b sin a t upon b, and y is given as a cos t minus b cos a t upon b. This is the problem. Now we'll move on to the solution. So our question is to find the maximum distance of the origin from any point on this curve given in this parametric form. So one thing is clear, whatever the point will be, its x coordinate will be looking like this, a sin t minus b sin a t upon b, and its y coordinate will be looking like a cos t minus b cos a t upon b. So let the farthest point from origin means coordinates 0 and 0, let the farthest point from 0 0 on this curve be p, and coordinates of p will be, x coordinate will be a sin t minus b sin a t upon b, and y coordinate will be a cos t minus b cos a t upon b. This will be the coordinates of the point P, and we have to find the farthest distance. First we have to find the distance between these 2 points. Let this point be O, origin. Then what is the distance OP? We know that the distance between 2 points x1 y1 and x2 y2. The distance formula is x1 minus x2 whole square plus y1 minus y2 whole square. So here it will be square root of this is your x1, this is your x2, x1 minus x2 whole square. So it is obviously only x1 square. So it will be a sin t minus b sin a t upon b, square of that x square, x1 minus x2 square, plus this is your y1 and y2 is 0. So y1 minus y2 whole square means y1 square. So it is a cos t minus b cos a t upon b square. So this is the distance. Now we can simplify it. When you will open the squares, the first term in the first bracket will be a square sin square t, and the first term in the second bracket will be a square cos square t. A square sin square t plus a square cos square t. You will take a square common, it will become sin square t plus cos square t, and we know that sin square t plus cos square t is 1. So it will be a square into 1, that means a square. So first term from this bracket and first term from this bracket, their sum will become a square. Similarly, plus the second term is b square sin square 80 upon b. Here it is b square cos square 80 upon b. Once again, b square will be common and sin square 80 upon b plus cos square 80 upon b will become 1. So the second term of first bracket and second term of second bracket, when sum up, it will give you b square. Now two terms are there, the mixed term from here and the mixed term from here. The mixed term here is minus 2ab sin t sin 80 upon b, and the mixed term in the second bracket is minus 2ab cos t cos 80 upon b. So let us have a little bit more simplification. So it is a square plus b square here, a square plus b square. From these two terms, you can take minus 2ab common. You can take minus 2ab common, and what you will get? You will get cos t cos 80 plus b, cos 80 by b plus sin t sin 80 by b. So cos x cos y plus sin x sin y, that means cos x minus y. So you can write t minus 80 upon b. This is the distance OP. And what we want this distance to be maximum. This distance will be maximum. This is a constant term. This is a constant term. Its maximality depends only on this term. And this is a negative term. So when it will be minimum, the distance will be maximum. And what is the minimum value of this cos t minus 80 upon b? The minimum value is minus 1. Minus 1 will will make it plus 2ab, a square plus b square plus 2ab it will become. So for distance OP to be maximum, cos of t minus 80 upon b should be minimum, that means minus 1, and in that case the distance OP will become square root of a square plus b square. This minus 2ab multiplied by minus 1 will become plus 2ab, and now it is nothing but a plus b whole square and then square root. So a plus b whole square in square root, the square and the square root will be cancelled once again, and you will get a plus b. So this a plus b is the maximum distance of any point on this curve from the origin. So this is the solution of this question, and we move on to the next question then. As I have promised, more harder problems are yet to come. If not in this video, then maybe in the next, or maybe in next to next video. But the next problem what we are going to take today, it is the problem, just write down. The next question is prove that tan x upon 1 minus cot x plus cot x upon 1 minus tan x is equal to 1 plus secant x cosecant x. This is the result we want to prove. So the proof of this question is not so difficult. So how to solve it? So we will move to the solution. I'll start from the left hand side. Left hand side is tan x upon 1 minus cot x plus cot x upon 1 minus tan x. First of all, what we have to do, just convert all these tan and cot into sin and cos. So this tan x will be sin x upon cos x, this will be cos x upon sin x, this will be cos x upon sin x, this will be sin x upon cos x. Then take LCM and simplify. What you are going to get is, here you will get sin upon cos and then cos upon sin here. Sin LCM will go in the numerator, you will get sin square x, and the cos x of the denominator and the numerator will come into the denominator, so it is cos x, and then taking LCM here, it is sin x minus cos x. Similarly, in the second, you will get cos square x upon sin x, and then cos x minus sin x. So now we have to take LCM of these two terms. This is sin x minus cos x, this is cos x minus sin x. So they are just negative of each other. So the LCM will be this cos x into sin x minus cos x. So LCM is cos x into sin x into sin x minus cos x. This is the LCM. So this cos x is there, sin x minus cos x is there. This sin x will be multiplied by the numerator sin square x. So sin square x into sin x will become sin cube x. As we have discussed that this cos x minus sin x is nothing but the negative of the sin x minus cos x. So this plus sign will be get converted into minus. This sin x is already here. This cos x minus sin x with sign change is already there. This cos x will be get multiplied with the numerator cos square x. So cos square x into cos x is cos cube x. Now, in the numerator, you are having sin cube x minus cos cube x. What we have to do? Just to factorize. A cube minus b cube. A cube minus b cube factors are a minus b, a square plus b square plus ab. So the factors will be the first factor a minus b, that is cos sin x minus cos x. The second factor is a square, that means sin square x, plus b square means cos square x, plus ab means sin x cos x. And in the denominator you are having cos x, sin x minus cos x. This sin x minus cos x is one of the terms in product in the denominator as well as in the numerator, so will be cancelled out. So what you will left with, this sin x plus cos square x will become 1. So this is 1 plus sin x cos x divided by sin x cos x. Now the final step, very easy. 1 divided by this plus second term divided by this. When second term will be divided by sin x plus cos x, the numerator and denominator will become same. So second term I am going to write first, it is 1 plus. So first term 1 upon sin x cos x, that means 1 upon cos x into 1 upon sin x. 1 upon cos x is secant x and 1 upon sin x is cosecant x. So that is what is there required in the right hand side. So we have arrived at the destination, right hand side. So this identity is being proved. So this was another important question from the point of view of examinations in competitions as well as in the board examination, or you can say the final examinations of 10 plus 1. Now we will move on to the next question. It is another very interesting problem of trigonometry. The question is if cos beta minus gamma plus cos gamma minus alpha plus cos alpha minus beta is equal to minus 3 by 2. Prove that cos alpha plus cos beta plus cos gamma is equal to 0 is equal to sin alpha plus sin beta plus sin gamma. That means we have to show that cos alpha plus cos beta plus cos gamma is 0, as well as sin alpha plus sin beta plus sin gamma is also equal to 0. And what we are given with? We are given with only one equation, that is cos beta minus gamma plus cos gamma minus alpha plus cos alpha minus beta is equal to minus 3 by 2, from where we will have to start for the proof. So what is the solution? we will once again start the solution. What in the first step I am going to do, this 2 in the denominator, I am going to take it to the left hand side. So each term in the left hand side will be get multiplied by 2. You will get 2 cos beta minus gamma plus 2 cos gamma minus alpha plus 2 cos alpha minus beta is equal to minus 3 now, because this 2 is being moved on the left hand side. Once again, this minus 3 I am going to take to the left hand side. When I will take this minus 3 to the left hand side, it will become plus 3, and your right hand side will become 0. It will be 0 here, and your left hand side will become 3 plus this term. Further, this 3, I am going to break this 3 into 1 plus 1 plus 1, 3 times. For the first one, I am going to write cos square alpha plus sin square alpha. For the first one, I have written this. For the second one, I am going to write it as cos square beta plus sin square beta. Plus, for the third one, I am going to write it as cos square gamma plus sin square gamma. Now, this cos beta minus gamma, we know that cos beta minus gamma is cos beta cos gamma plus sin beta sin gamma, and it is multiplied by 2, so both the terms will be twice. So what you will get? Plus 2 cos beta cos gamma plus 2 sin beta sin gamma. Similarly, this is done the second term. Similarly, it will become plus 2 cos gamma cos alpha plus 2 sin gamma sin alpha. This is done, and the final term, in the same manner, similarly, it can be written as plus 2 cos alpha cos beta plus 2 sin alpha sin beta is equal to 0. Now look at what the terms I am going to take now. This cos square alpha plus cos square beta plus cos square gamma plus 2 cos beta cos gamma plus 2 cos gamma cos alpha plus 2 cos gamma cos alpha. Look at this combination. A square plus b square plus c square plus 2ab plus 2bc plus 2ca. That means a plus b plus c whole square. So these terms what I have marked, they are going to turn into a bracket, that is cos alpha plus cos beta plus cos gamma whole square. A plus b plus c whole square. A square plus b square plus c square plus 2ab plus 2bc plus 2c. Similarly, the rest of the terms. A square plus b square plus c square plus 2ab plus 2bc plus 2ca. The same manner, similarly, it will turn into sin alpha plus sin beta plus sin gamma whole square is equal to 0. Now, sum of these two terms is 0, and none of these is negative, because it is a perfect square, it is also a perfect square. So this is a positive quantity, you can say non-negative quantity. This is a non-negative quantity, this is also a non-negative quantity. Sum of two non-negative quantities is equal to 0 is possible if and only if each one of these is 0. So this is non-negative, this is non-negative, their sum is 0, implies that both the quantities, that means cos alpha plus cos beta plus cos gamma must be 0, as well as the second term sin alpha plus sin beta plus sin gamma must also be 0, because sum of two non-negative quantities cannot be otherwise 0. It can be 0 if and only if both the quantities are 0, and this is what the required result we are to prove. So this is the proof of this question. So this was a very interesting question. The proof was a little bit tricky, And then we will move on to another question that may be a little bit tricky. As we are moving ahead, questions are going to be more and more tricky. So the next question I am going to take is, this is the question here. I am going to take the next question. It is, if sin x plus sin square x is equal to 1, evaluate this term. This is cos raised to the power 12x plus 3 cos power 10x plus 3 cos power 8x plus cos power 6x plus 2 cos power 4x plus cos square x minus 2. This we are to evaluate. We are just given that sin x plus sin square x is equal to 1. So I am going to start with the given equation for the solution. This sin x plus sin square x is equal to 1 implies sin x is equal to 1 minus sin square x, and we know that 1 minus sin square x is cos square x. So cos square x is coming out to be equal to sin x. So whatever is required to be evaluated, replace every cos square x by sin x. So the required term is equal to this cos power 12x, because cos square x is sin x, so this cos power 12x will become cos raised to the power 6x. This 3 cos 10x will become 3 cos power 5x plus this 3 cos 8x will become, this is sin. This is going to be converted into sin because cos square x is equal to sin x. So this cos 8x will be 3 sin 4x. This cos 6x will be sin cube x plus this 2 cos 4x will be 2 sin square x. This cos square x will be sin x, and at the end minus 2. Now look at these 4 terms. This is nothing but sin square x plus sin x cube. Actually, a plus b whole cube is a cube, which is here, plus b cube, which is here, plus 3a square b, which is here, and plus 3ab square, which is here. So these 4 terms will be collected and will be made to sin square x plus sin x whole cube plus. Now we are left with 2 sin square x. This 2 sin square x I am going to break as sin square x plus sin square x, then plus sin x, and then minus 2. This sin square x plus sin x is given to be equal to 1. So it is 1 cube plus sin square x. This sin square x plus sin x is once again equal to 1 and minus 2. This 1 cube is 1, and 1 plus 1 minus 2 will be cancelled out, and we will be left with only sin square x, which is the required evaluation of the given term. So given term is equal to sin square x. So it was another interesting question. And then I am going to move most probably the last question of today, which will be again very interesting. So let us take the last question of the day. Evaluate 1 plus tan 1 degree, 1 plus tan 2 degree, 1 plus tan 3 degree, and so on up to 1 plus tan 45 degree. We have to evaluate this quantity, this term. Before moving on to the question, to the main question, one identity I am going to solve. that 1 plus tan theta into 1 plus tan 45 degree minus theta, what it is equal to. So let us take, it is 1 plus tan theta, 1 plus this tan 45 minus theta, we know that it is equal to 1 minus tan theta over 1 plus tan theta. So it is equal to 1 plus tan theta in the first bracket. In the second bracket, take out LCM as 1 plus tan theta. In the numerator, you will get 1 plus tan theta plus 1 minus tan theta. This 1 plus tan theta will be cancelled. This tan theta will be cancelled. And this is 1 plus 1 is equal to 2. So this 1 plus tan theta and 1 plus tan 45 minus theta is coming out to be equal to 2, and that is our key factor in solving this problem. So let us see how it will help in solving the problem. Now I am going to take pairs from this given term. This 1 plus tan 1 plus tan 1, I am going to pair it with 1 plus tan 44 degree. This is first pair. Then 1 plus tan 2 degree, I am going to pair it with 1 plus tan 43 degree. Then 1 plus tan 3 degree, I am going to pair it with 1 plus tan 42 degree, and so on. 1 plus tan 22 degree will be paired with 1 plus tan 23 degree, and one term, the last term, 1 plus tan 45 degree will remain. So I am writing it as a separate term. Look at the first bracket. It is 1 plus tan theta, 1 plus tan 45 minus theta, and the value of this correction is going to be 2. So this term is equal to 2 multiplied by, similarly it is again 1 plus tan theta, 1 plus tan 45 minus theta. So this is again going to be equal to 2 multiplied by, this is again going to be equal to 2, and so on. It is again going to be multiplied by 2. And how many terms are there? This is tan 1, tan 2, tan 3 up to tan 22. So these are in collection 22 terms, and multiplied by one more term is there. Tan 45 degree is 1. So this 1 plus 1 is again 2. So 1 more 2. So how many total terms are there now? These are now 23 terms. So 2 multiplied by 2 multiplied by 2, 23 times is going to be equal to 2 raised to the power 23, which is the required answer of the given question. So I think you are liking these questions. You are being benefited by these questions, by these techniques. And before ending this video once again, I request you to like these videos, to share these videos with your friends who are in 10 plus 1 stage, are going to appear in any type of competitive examinations like IIT, JEE, MNR and so on, or NDA you can say. And I will once again request you to subscribe my channel Knowledge Entertainment to get more and more videos of this kind, because all the solution of questions of 10 plus 1 complete syllabus, then 10 plus 2 is going to appear on this channel for your benefit, for your guidance. So in advance, I would like to thank you for liking and subscribing my channel. Thank you.